All right. So, yeah, the 19th question. So this question is on the bowling average. Do you guys know how is the bowling average calculated? So bowling average is calculated as number of runs upon number of wickets taken by a bowler. So in fact, for a bowler, from a bowler's perspective, lesser the bowling average, it's better. So lesser runs given per more wickets taken is better as a bowling average. Do you understand this?
Yes, ma'am.
So this is the only catch in the question. So who had a doubt? Rachel, you had a doubt, right?
Yes, ma'am.
So was this your doubt or uh, what was it?
I was unable to solve this problem.
Okay. So if I consider this bowling average, now let's read the question. The bowling average of a cricketer was 12.4. He improves his bowling average by 0.2 points when he takes 5 wickets for 26 runs in his last match. Okay, so initially his bowling average was 12.4. He improves his bowling average by 0.2. So, what is his improved bowling average? 12.6 or 12.2?
0.2.
12.2. Why? Because when I say I improve my bowling average is better when it goes down. So 12.4, say 12.2 is the improved bowling average. 12.6 will be a worse bowling average compared to 12.4. Okay. And this happens when he takes 5 wickets for 26 runs in his last match. So find the number of wickets taken by him before the last match. So let's say number of wickets taken by him before the last match is X. Okay. So I know that bowling average is 12.4 before the last match. So bowling average into number of wickets X will give you the total number of runs. Agreed? Right? So this will be the total number of runs before the last match plus these 26 runs in the last match will give you an improved bowling average into total number of wickets now become X plus 5. This is old runs plus last match runs is equal to total runs. Entire equation is in terms of runs, where runs is nothing but bowling average into number of wickets. You understand this?
Yes,
Yes.
ma'am.
So, once you solve this question, once you solve the equation, which is now gone. So, once you solve this equation, you will get the value of X, and X is what is asked to you.
Okay, ma'am.
Any doubt here? Okay.
No.
All right. Yeah.
Ma'am, can you tell the answer for the 20th one since there are no options there? So I just wanted to
For the 20th one is 10.
Ma'am, I got 11 as the answer.
Just that. Sorry, sorry. The answer would be 11. My mistake. The answer would be 11 for the 20th question. Okay. So today we are going to do an important, interesting, easy topic called allegations and mixtures. So yesterday in one of the questions, I already introduced a method which is the key to this topic. But again, we'll do that in detail today. And then we'll do the related questions. So you'll understand where is this applied. Basically, more than a topic, it's like a method which you can apply in a lot of topics that we have done up till now also, if you have a particular type of a question. Okay? All right. So this method is basically related to weighted average. Wherever in whatever topic, if you have a question which relates to weighted average, most of the time this method will be applicable. Now let's do a simple question of weighted average. Okay, let's say there are, let's say, 40 girls in a class whose average weight is 60 kg. Then there are 30 boys in a class whose average weight is, let's say, 70 kg. Okay. What will be the average weight of the class? I'll just change little, just a second, so that our calculation is easy, nothing else. And I'll make it to 60 boys in a class. Okay, so that I can explain you better, no problem. So if this is the data, what is the average weight of the class? Now, how do you calculate average weight of the class?
Total weight upon number of students.
So tell me what would be the numbers I would be calculating?
40 into 60 plus 280. So 240 plus 480.
400 plus
800.
4800. Okay, divided
100.
100. Right. So this is going to give me 24 plus 48 is nothing but 72 as the average weight of the class. Is everybody clear with this? Okay.
Yes, ma'am.
Now, if I have to convert this entire weighted average problem into a different format of writing, which includes allegations and mixtures. So basically, now how I would see this question as, I am mixing two things. Which are my two things? There are these girls and there are these boys. Okay, so I'm mixing two things to form a mixture. Now the girls have an individual average weight of 40. Boys have an individual average, sorry, girls have an individual average weight of 60. Boys have an individual average weight of 80. And the average weight of the mixture is 72, which will be written in between. Okay. So first thing about these three numbers, what have you to be very sure about these three numbers is, first thing is the middle number always has to lie somewhere in between the other two numbers. Do you agree with this?
Yes, ma'am.
Can the average of the class be less than 60 or more than 80?
No.
Not possible. Okay, that is the first thing. Second thing is, what is 72 closer to, 60 or 80?
80.
80, right? Which means the proportion of boys has to be more than the proportion of girls in the class. Do you understand this second conclusion?
Yes, ma'am.
Okay. And the third thing is, all these three numbers necessarily have to represent the same unit. If 60 is the average weight, 80 is the average weight, 72 has to be the average weight. Out of all these three numbers, none can represent a different thing. Okay, so now if I take the difference of 60 and 72, I will write the difference in the same line. Observe this carefully. 60, 72, the difference is 12. 80 and 72, the difference is 8. So 8 is to 12, the ratio is nothing but 2 is to 3. So what do I mean by this is, when girls and boys are mixed in the ratio 2 is to 3 respectively, where girls the weight is 60 and boys the weight is 80, the average will always come down to 72. Now, if you observe here, in the example that we took, the number of girls were 40, number of boys were 60, the ratio was 2 is to 3. Instead of 40 and 60, if our girls and boys would be 20 and 30, still my average would come to 72. Okay, so does not matter what number, but the ratio of girls and boys has to be 2 is to 3. Okay.
Yes, ma'am.
All right. So, in this case, I mean, now when I talk about allegations as a question, these are the 5 places that they are talking about. I'll just use a different pen color. This is one place, this is another place, this is another place, and they are talking about this ratio and this ratio. So now out of these 5 places, one of the place you will have to find, and other things will be given to you. In the weighted average, necessarily you had to find this. But in the allegations question, when I convert it, not necessarily that would be the unknown thing, but one of the things out of these 5 will be unknown, where you will have to figure out that unknown part. But did you understand the format of allegations?
Yes, ma'am.
Okay. Right. So, for example, let me give you a very simple question. Let's say I am taking 2 different qualities of rice. Okay. One quality is the one where you get the rice at 66 rupees per kg. Another quality is such where you get the rice at 90 rupees per kg. In what ratio should I mix these 2 qualities of rice so that my average of the mixture comes down to 80 rupees per kg? So how will you do it?
So we'll write 66 and in
In between there would be 80, correct? So this is going to be 10 and this is going to be 14. So in what ratio will the rice have to be mixed? Both the qualities of rice will have to be mixed in
5.
So if the question would have been, instead of asking the ratio, if the question would have asked, so how much kg of second quality will have to be mixed with 50 kg of first quality? With 50 kg of 66 rupees per kg, how many kgs of this quality will have to be mixed?
70.
So instead of ratio, they could have asked the quantity also. Okay. All right. Let me give you one more question then. Let's say that there is one quality of rice at 66 rupees per kg. At a cost price of 66 rupees per kg, I want to mix this quality of rice with another rice at a cost price of 90 rupees per kg, such that if I sell the mixture, see, be careful of what am I asking, at rupees 84 per kg, I earn a profit of 9.09%. Sorry, write it again. Did you understand my question? I want to mix 2 different qualities of rice, one which costs me 66 rupees per kg, another costs me 90 rupees per kg. So when I mix them and sell the mixture at 84 rupees per kg, I earn a profit of 9.09%. In what ratio should I mix them? Now, what will be the difference in this question compared to the previous one?
We need to make sure that profit is 9.09.
So, how would I make sure of that? So, when I write 66 and 90, will I write 84 in between? See, I told you 3 rules. What was the first rule? The middle number has to be in between, which is not a problem over here. Second rule was closer to the whichever side it is closer, the proportion of that side has to be higher. And the third rule was that all the 3 numbers should indicate the same thing. Now, what is 66 rupees per kg? Cost price of first quality. What is 90 rupees per kg? Cost price of second quality. What is 84 rupees per kg?
Selling price.
So I can't write cost price, selling price. What will I have to do? I will have to convert this selling price to cost price first. Now, if selling price is 84 and profit is 9.09%, what equation do you write to connect selling price, cost price, and profit? Profit and loss. We have done this. Come on. Do we remember this relation?
The cost price will be selling upon multi.
Correct. So your multiplier, what will be your multiplier?
12.
12 by 11, no, because it's a profit. The multiplier will be 1 plus 1 by 11. So this gets cancelled and your cost price is 77. Did we understand this?
Yes, ma'am.
Yes, ma'am.
Yes. So now this becomes 11. This becomes 13. So both the qualities of rice will have to be mixed in this ratio. Yes, it is very important that all the three numbers indicate the same thing. Okay, let me give you one more example. I had some amount to be invested in. They were my savings, and I had some amount to be invested. I invest in scheme A, which gave me ultimately 12% profit. Okay. I invested some part in scheme B, which made a 5% loss for me. And overall, my portfolio was at 8% profit. In what ratio did I invest in scheme A and in scheme B? How will I write it? Three numbers.
They are all profit. Can we mention it like 12%, 5%, and in between 8%?
Did we understand why?
Yes.
The difference here will be 4. What will be the difference here? 3 or 13?
13.
Yes, somebody was asking something.
Ma'am, so we took 8 there by following the rule that the middle number is in between.
Not because of that. Because two things that are mixed over here is scheme A and scheme B. And
So then overall, okay, got it.
yeah.
So ma'am, that rule then doesn't apply everywhere, right?
It applies everywhere, and that rule is for us to check whether we have put the right numbers at the right place. But it will apply everywhere. The total, the final average can never be beyond the other two numbers. It is not possible.
Okay. Thank you, ma'am.
Okay. All right. Then let's see one more type of question in this. Let's say instead of mixing two things, what I'm saying is there is a mixture A which has milk and water in the ratio, let's say 3:4. There is a mixture B, okay, which has milk and water in the ratio, let's say 1:2. In what ratio should I mix mixture A and mixture B so that final ratio of milk and water in the third mixture is 2:3. Did you understand my question first? So there is a mixture A in one container. There is a mixture B in one container. I want to mix both of them in certain proportion to create a mixture C. Okay. Now mixture A already has milk and water in 3:4 ratio. Mixture B has milk and water in 1:2 ratio. And mixture C should have milk and water in 2:3 ratio. Do we understand this question?
Yes, ma'am.
Okay. Now in this case, how is it different from the previous questions is, in the previous questions, we mixed a single component. Whereas in this question, we are mixing mixtures. So mixtures themselves have different components. So here you can directly not take my three numbers, but what you'll have to do is you'll have to pick up any one component out of the two. It can be any one. It will not change your answer. Let's say I pick up milk, for example. So what is the proportion of milk in mixture A?
3 parts.
3 out of 7.
7.
What is the proportion of milk in mixture B?
1 out of.
Correct. And milk in mixture C?
2 out of 5.
2 out of 5. So now I am going to use my allegation on this. So what is 2 by 5 minus 1 by 3? You can just calculate 2 by 5 minus 1 by 3. 2 3s are 6, 5 1s are 5. It's going to give you 1 by 15. Right? Calculate this. What is 3 by 7 minus 2 by 5? Why am I not getting up first?
1
1 by 35. Right? So this is the final ratio I'm getting, which if I cross multiply, I can say that mixture A and mixture B will have to be mixed in the ratio 7:3. Do we understand this?
Yes, ma'am.
Even
Yes,
if you
ma'am.
would have taken water instead of milk, your answer would still be 7:3. Your answer will not
So we are
change.
supposed to take average for one element, not for both of them.
Yeah, any one
But
element you can pick up, but not taking both of them together. That would not be possible. So this ratio that you are getting is the ratio for the entire mixture. Doesn't matter. Because you have taken the proportions of the elements, no? So that already inculcates the mixture part.
um,
Okay. Now let us solve few questions first on this concept that we have learned, so that we are sure that we are able to apply it and you'll understand better also. And in the questions, if we come across any new type, I'll explain it then and there. Fine?
Yes, ma'am.
Okay. Yeah. Now can you see?
Yes, ma'am.
yes.
So let's start with the first question. Two solutions of milk and water are mixed in the volume 2:, mixed in the ratio 2:3 by volume. See, already the ratio is given to me. So there are two solutions of milk and water. Always try to draw like this, where they are already mixed in the ratio 2:3. You need to understand why am I placing these numbers and where. So if you don't understand that, please ask. Okay. The resultant solution contains 40% milk, which means in between, if I have to say the milk concentration is 40%, find the milk concentration in the first solution if the milk concentration in the second solution is 60%. Did you understand my placement?
Yes, ma'am.
All the three numbers are in terms of milk solution concentration. So if, because this is in 40%, this is in 60%, even the first question mark that I will get will be in terms of percentage of milk. So that does not make a difference. Okay. Now, what is the difference between 60 and 40?
20.
20.
So
So what should be the difference between 40 and the other number?
30.
30. So now if the difference is 30, the number should be 10 or 70. The number can
It
be 10 or 70, right?
it's 10
Why not 70?
because it cannot be off the range, so it has to be in between.
Very good. 40 has to be in between 60 and the other number. So the other number cannot be 70. It has to be lesser than 40. Do we understand this? It's a very important topic as far as your exams are concerned, because if you get the questions from this topic, you should definitely solve them because they are pretty scoring and they are pretty quick to solve. That is why I don't mind taking more time right now to make sure that you understand what we are doing. This is the shortest method that you can apply.
Ma'am, can you just go over it once more?
Sure. So first see what two things are you mixing. Always ask this first question to yourself. What am I mixing? Are you mixing milk and water? No. What are you mixing? You are mixing two solutions. So two solutions themselves contain milk and water. So this is solution 1, this is solution 2. They are already mixed in the ratio 2:3. So you already have the final ratio with you. The resultant solution has 40% milk. So 40% milk has to come in the center. Find the milk concentration in the first solution if the second solution has a milk concentration of 60%. You have to be clear that this question mark, this 60%, and these 40%, all these three things represent the same thing. So do they represent the same thing here?
Yes, ma'am.
That's it. Now, whatever we
Got
learn,
it.
you just have to do it reverse.
Yes, got it, ma'am.
As I said, out of the 5 things, one thing will be unknown. Fine. Moving ahead. Come on. Now, I want you to make that cross for me. A vegetable vendor mixes 68 kg of tomatoes purchased at 63 rupees per kg with 85 kg of tomatoes purchased at 81 rupees per kg. So how would you make the cross thing here?
Do we take the cost per kg or the total cost?
Total cost. Already the cost is given to you per kg, no? So you'll have to take that only because what is asked to you is also per kg. See? So here, what would be the 3 things? What are the 2 things you're mixing? First, tell me that.
The tomatoes purchased at different prices.
Correct. So first quality is purchased at 63. Another quality is purchased at 81. Correct? And the average price of the mixture is unknown. Clear?
Yes, ma'am.
Now, what is the quantity of tomatoes given to you? 68 kg and 85 kg. If I have to reduce the ratio, what does the ratio come down to? Because this nothing but comes from the ratio, right? So what does the reduced ratio come down to? My problem is if we don't know the tables, there is no way we can be faster than the other fellow students. 68 is 17 fours-a and 85 is 17 fives-a. So what is the reduced ratio?
4:5.
Are we clear? Why did we get the ratio here? So clearly, we need a number between 63 and 81 such that the gap is divided in this ratio. Do you understand this?
Yes.
What is the gap between 63 and 81 in terms of numbers? How much is the gap? 81 minus 63 will give you 18. So if I have to distribute this gap of 18 in the ratio 4:5, what will be the distribution? Come on, you're right. So if 18 has to be divided in the ratio 4:5, what will be the two numbers?
8 and 10.
Correct, 8 and 10. So 81 with a gap of 8 will come down to which number? Or 63 with
73.
a gap of 10? Both of these have to come down to the same number. Did you understand this? So what is the average cost price of the resultant tomatoes? 73 rupees per kg. Now, you could have also solved this question with the basic regular weighted average method that you have already learned. 68 into 63 plus 85 into 81 upon 68 plus 85. But don't you think this will be really tedious?
Yes, ma'am.
This will give you the same answer, 73. But because the numbers are not very friendly, this would not be a preferred method according to me.
Yes.
Okay? Are we clear with this? If the center number is absent, what are you supposed to do? The quantities has to be written on the top. After that, the cross starts. And if the center number is absent, you need to distribute the difference in the ratio. All right.
Yes, ma'am.
Then let me move ahead. Okay, let's look at this. Ratios of milk and water in two solutions are, so again we are talking about two solutions where milk and water is 2:3. In another, milk and water is 3:2. Then what is happening? Content of both of these solutions are mixed in the ratio 1:4. Now, did we understand this, what I have written?
Yeah.
So I want everybody to come with this structure first by yourself and then verify from the screen. This is very important. If you don't get this, you will not be able to solve further. Okay. Now, what did we learn when we are mixing two mixtures? What did we learn about that?
To take just one of them. So 2/5 parts of milk and 3/5 parts of milk.
Correct. So I'm going to write it separately in terms of milk because I cannot solve from this cross that I have made. So in terms of milk, 2/5, 3/5, I don't know the center part, but I know that the final ratio has to be 1:4. Agreed?
Yes, ma'am.
Now 2/5 and 3/5. What is the gap over here?
1/5.
1/5. So if I have to distribute the gap of 1/5 in the ratio 1:4, which looks little tedious to me. How about just to ease it off for me, what I would do is I'll multiply both these values by 100. So if I multiply this by 100, this becomes 40 and this becomes 60. In short, I converted into percentage. Okay. So now what is the gap between 40 and 60? 20. So if I distribute 20 in the ratio 1:4, how do I distribute?
4 and 16.
4 and 16. So what will be the number which gives 40 say difference 16 and 60 say difference 4?
56.
56. But I converted 2/5 and 3/5 by multiplying by 100. So if I have to reconvert 56, what will I have to do?
5,600.
Correct. So what does this come down to? If I cancel by 4, it is 4 ones are 14s are and 4 25s are. Correct? Which means what is the proportion of milk in the final ratio? 14 by
25.
5. So what should be the proportion of water in the final ratio?
11/25.
Correct. And that is why what should be the proportion of milk and water in the final ratio?
14:11.
So in case you are stuck with fractions, you can always convert them to whole numbers and then reconvert them after you get the final answer.
Got it, ma'am.
Okay, all of us, I hope no doubt. All these are good
Yeah.
variety of questions. If you understand all this variety, you will be really through at this topic. Next, let's try to look at this. 68 liters of milk was added to 3:7 milk to water solution, and the ratio of the resulting solution had milk and water in the ratio 7:5. What is the volume of the original solution? So again, the same question I'm going to ask. What are we mixing?
Just milk to an already existing.
Very good. We are mixing milk to a solution. We are not mixing milk and water. Very good. We are mixing milk to a solution to form the resultant solution. Right? So we are mixing milk to a solution to form a resultant solution. Now, milk, if I talk about milk, clearly it is pure milk, so there will be no ratio of water. The solution has milk and water in the ratio 3:7, and the resultant solution has milk and water in the ratio 7:5. Right? Again, it is mixture, so I'll have to take up one component. So which do you want to take up, milk or water? Pick up any one component. And you know that 68 liters of milk is mixed. Okay. Now pick up any one component, milk or water. You want to take up water this time?
Yes, ma'am.
You can pick up anything. Okay. So if I'm taking up water this time, okay, let me pick up water. What is the component? What is the proportion of water in the first part?
7/10.
That is here. What is the proportion of water in pure milk?
0.
0 is correct. And if I would have taken milk, what would be the proportion of milk in pure milk? 1. Because everything is in terms of fractions. Do you understand this?
Yes, ma'am.
And this would be 5/12, right? So let us find the ratio. I know that the quantity of this part is 68 liters. I need to find the quantity of this part. So first let us try to find the ratio. 0 minus 5/12 will be 5/12. What is 7/10 minus 5/12? Calculate and tell me. What is 7/10 minus 5/12?
17/60.
Possible. 17/60. So if I have to now compare these two ratios, so 17/60 is to 5/12. Just for the ease of my calculation, I'll convert this ratio into, I'll multiply both sides by 5. So it will become 25:60. Is this okay?
Yes, ma'am.
So I can say my ratio is 17:25, my final ratio. So if 17:25 is the final ratio, for 17 parts, 68 liters of pure milk is taken. So for 25 parts, what should be the solution taken? 17 fours are 68. So this side should be 25
100.
fours are 100. Do we get this?
Yes, ma'am.
Okay, you have the quantity of one part. You need to find the quantity of other part, and that quantity will come from the final ratio. Again, I'm repeating, instead of water, if I would have taken milk, my allegation would have looked something like this. Still, when I solve it, I would have got the same ratio. Do we get this?
Yes, ma'am.
Yeah? All right. Moving further then, let's look at this. The ratio of quantities of acid and water in a mixture is 1:3. If 5 liters of acid is further added to the mixture, the new ratio becomes 1:2. What is the quantity of the new mixture? How would you do this? Or what are the two things that we are mixing?
So acid and water is already in a, we are adding acid to the already existing mixture.
Correct. So we are adding mixture plus acid to form a mixture, right? Now this answer cannot be wrong. So the mixture has acid and water in the ratio 1:3. Pure acid is of course pure acid. What is the quantity of pure acid given to you? 5 liters. And the new
5
ratio uh, in the mixture of acid and water becomes 1:2. What is the quantity of new mixture is asked. So, how would you solve this? Come on, next step. Now I want you guys to answer quickly because we have done this earlier already. Next step.
We take just one element here.
So take element of your choice. What you want to take?
Acid.
Sorry.
Acid.
Okay. So tell me the numbers. 3 numbers if we take acid.
1/4
Hmm.
and water acid and 1/3.
Okay. So what will be the ratio that you're getting? One minus 1/3 is 2/3. What is 1/3 minus 1/4? What is 1?
1/12.
1/12. So if I have to, let's say if I multiply this with 4 on both the sides, this becomes 8/12. Agreed?
Yes, ma'am.
So what is the final ratio that you are getting?
8:1.
8:1. So if 1 is 5 liters of acid, the 8 parts has to contain how much quantity of the mixture?
40 liters.
40 liters. So what is the quantity of the final mixture?
55.
Correct. Are we getting this, girls? So if 40 liters of mixture is mixed with 5 liters of acid, you get this proportion where the quantity is 45 liters, but the proportion is 1:2. Do we understand this situation?
Yes, ma'am.
Now, there is one more way of doing this question, which might be easier in this type. So, I know that the ratio of quantity in acid and water initially is 1:3. So, let's say acid I can take as X and water I can take as 3X. Okay. Now 5 liters of acid is added and the final ratio becomes 1:2. So I can write the equation as x plus 5 upon 3x is 1:2. So 2x plus 10 is 3x and thus x is equal to 10. So when I put x is equal to 10, total quantity of acid becomes 15, total quantity of water becomes 30, and total quantity of mixture becomes 45. Okay, so of course, in this type of question, you might prefer a second method, which is completely okay. Whatever strikes you first. All right, moving further. What quantity of each of two milk water solution having milk and water in the ratio, so this is 5:4, first solution, second solution is 2:1, what quantity of each needs to be taken and mixed to form a solution in which the ratio of milk to water is 1:1. Can you try this and tell me the answer?
Ma'am, is the ratio coming 3:1?
Okay, how? Could you tell me the steps?
So we take the fraction 9
The first
by
fraction, what did
3,
you take? 5/9 or 4/9?
5/9 for milk,
Hmm.
and 2/3.
Hmm.
So the difference is coming 1/6.
2/3 minus 1/2 is 1/6.
1/6. And 5/9 minus 1/2 is 1/18.
So, which means that you are saying that both 2/3 and 5/9 are greater than 1/2?
Yes.
Is that possible? The first rule of allegation, the center number has to be in between the other two numbers, which means it has to be greater than 1 and less than 1, right?
Yes.
In this case, both 2/3 and 5/9 are greater than 1/2. So, because this is the case and this rule is violated, which means it is never possible that when I mix mixtures in these two ratios, I get a third mixture which has this ratio. We should not
Okay.
forget the basic rules. Okay? Is everybody getting this?
Got it, ma'am.
Oh, all right. Moving ahead. Bottle 1 contains milk and ratio. Okay, so let us say this is bottle 1, which contains milk and ratio in 7:2. Then this is bottle 2, which contains milk and ratio, sorry, milk and water in the ratio 9:4. In what ratio of volumes should both be mixed so that I have the final ratio as 3:1? Now tell me the answer to this. Come on, I'm expecting answers. I'm just solving here because I don't have anything else to do.
Ma'am, the fractions are 3/36.
So if nothing happens, you can just cross multiply and get the ratio also, no? 3 into 36 is 108
Oh, wait.
is 252. See if you can reduce this further. If I reduce it by 4, what do I get?
27:13.
So that should be your answer. Okay. Next. There are two drums, each containing a mixture of paints A and B. In drum 1, A and B are in the ratio 18:7. The mixtures from drums 1 and drums 2 are mixed in the ratio 3:4. In the final mixture, the drum A and B is 13:7. In drum 2, what is the ratio of A is to B? And they are mixed in the ratio 3:4. Has everybody drawn this in your book by yourself?
Yes, ma'am.
Okay. So first thing is, of course, I'll have to pick up any one of A or B. So whatever you want to pick up. Let's say if I pick up B because B looks like a smaller number to me, right? So if I take up B, this is what? 7 upon
25.
25. This I don't know. And this is 7 upon 20.
20.
And I know that the ratio is 3:4. Now As I told you last time, if you are not very comfortable with fractions, you can always convert them into whole numbers also for your ease of calculation. If you want, you can do that. So if I convert it into 100, I mean, if I multiply it by 100, what does this become?
28.
Okay, so this will become 28. And if I multiply this by 100, it becomes
35.
35, right? So 28 and 35. The difference is, this is more complicated than we thought. Mixtures from grams 1 and 2 are mixed in the ratio 3:4. 13:7, 8. Just rechecking my values if nothing has been wrong. Okay, okay. So fine. This looks little, because of course if I see the answers are also not very friendly, no problem. So 28 and 35, the difference is 7, right? So if in the difference of 7 the ratio is 4, for the ratio of 3, what should be the difference? 3 into 7 upon 4, which is 21/4. So I don't think we should be adapting this method in this particular question, because it is not leading us to very great numbers. So what I can directly do instead is, see, 7/25 and 7/20. I know that this number is larger than 7/25, right? So I can directly write my ratio over here. 7/20 minus 7/25 upon x minus 7/20 is 4/3. Did everybody understand this equation that I wrote? Yes?
Yes, ma'am.
Yes,
Now
ma'am.
if I take an LCM over here, the LCM comes down to 100, of course, where 5 sevens are 35 and 7 fours are 28. So you're coming down to 7/100 upon, this is
26 minus 7.
correct, upon 20. So if I cancel out upon 20 and 100, this becomes upon 5. Clear what I did?
Yes, ma'am.
Cross multiply and tell me the value of x. X will come in terms of fraction. So tell me the value of that fraction.
Is it 49 by 400?
Possible. Is everybody getting that? 49. Do you want to solve again? Is anybody else getting the fraction of x?
For 10 by 5, we multiply 5 by 20x minus. Then we get 21. After cross multiplying, we get 21 is equal to 400x minus 28.
Minus 400x minus 4 into 28 you should get, no? Sorry, minus 35. This is 5 into 2. So it should get
Okay, it will be 35 into 4 then. Yeah.
So now what are you getting? (161 upon 400).
161 upon 400.
Right. So when I say x is 161 upon 400, which means the proportion of paint B is 161. So proportion of paint A will be 239. All right. Moving ahead, let's look at this. The cost of oil is 100 rupees per kilogram. After adulteration with another oil, which costs 50 rupees per kilogram. So first oil was 100 rupees per kilogram. It was mixed with another oil which cost 50 rupees per kilogram. Ram sells the mixture at 96 rupees per kilogram, making a profit of 20%. So if selling price of the mixture is 96 rupees and profit is 20%, What is the cost price of the mixture? How will you find it? What will be the equation?
96 is equal to cost price into 6 by 5.
Very good. So what should be your cost price?
80.
Your cost price is 80, so that is going to come in between. Do you understand this? So in what ratio are the two qualities mixed?
3:2.
Very good. Are we clear with this?
Yes, ma'am.
Okay. Next, let's try this. How many kg of sugar costing 11 rupees per kg? So I don't know the quantity of this. Should be mixed with 21 kg of 9 rupees per kg sugar so that there is a profit of 10% by selling a mixture at 10.45 rupees per kg. Did you first understand why I wrote 21 and question mark above these figures?
That is the quantity that is mixed.
Correct. So now first you tell me the cost price of mixture. Calculate and tell me the cost price of mixture.
Nineteen by 2, so 9.5.
9.5. So I'll write 9.5 over here. Correct? So 11 and 9.5. What is the difference?
1.5.
And 9 and 9.5, the difference is?
0.5.
So what is the ratio? Correct? 0.5 and 1.5.
Yes, ma'am.
So if 3 parts is 21, one part should be?
7.
Are we clear?
Yes, ma'am.
Okay. Next, let's look at this. Goods are purchased for 450 and one third of them are sold at a loss of 10%. At what percentage profit should the remainder be sold so as to gain 20% on the whole transaction? Okay, now there are two ways to do this. One that we do purely by profit and loss, and another that we do by allocations. Let me show you both the methods. Okay, if I do purely by profit and loss, goods are purchased for 450, one third are sold at 10% loss. So 450 ka one third is 150, the cost price of the one third goods, and the cost price of remaining two third goods is 200, 300. Is everybody getting this?
Yes, ma'am.
Now, when I sell these 150 at a loss of 10%, which means I'm gaining 15 rupees less for this. So I'm gaining 135 rupees. And overall, I need 20% on the transaction, which means on 450, if I want to earn 20%, which means I want to earn 90 rupees. So I basically want a total of 540 in my pocket. Do you understand this?
Yes, ma'am.
So to get a total of 540 in the pocket, where 135 I've already got, how much more do I need? Correct?
305.
Good.
405.
So
Yeah.
to earn 405, how much profit do I need to earn on 300?
105.
So to earn a profit of 105 on 300, what should be my profit percentage? 105 on 300 is equal to what percentage?
35.
Correct. But is this method clear? Without my help, would you be able to contemplate these steps?
Ma'am, can you just go over it once more?
Sure. So see, I've purchased certain goods for 450 rupees. So 450 is my total cost price. Now one third I'm selling at 10% loss. So for goods worth rupees 150, I'm bearing a loss of 10%. So I'm getting back only 135 for them. Okay.
Got it, ma'am.
For goods worth rupees remaining 300, I don't know at what price should I sell them, but I want the overall profit of 90 rupees in my pocket. So I'm calculating it backwards.
Got it, ma'am.
Okay. Now let's do an allocation method. So for goods worth rupees 150, I am suffering a loss of 10%. So I'm writing minus 10. And for goods worth rupees remaining 300, I don't know what profit or loss should I suffer, but I want a overall 20% profit. Did you understand this?
Yes, ma'am.
Now 150 and 300, the ratio is 1 is to 2. So this final ratio should be 1 is to 2. Now minus 10 and 20, what is the difference?
30.
30.
So if 2 parts is 30, 1 part should be
15.
15. So for a difference of 15 from 20, what should be the number here? 20 obviously has to lie between minus 10 and the other number. So for a difference of 15 from 20, it can be either 5 or 35. But 5 is not possible because both the numbers will be on the lesser side. So answer has to be 35. But did you see the magic of this method compared to the traditional method?
Ma'am, how did we get the ratio of 1 is to 2?
150 is to 300 because for one
Okay.
part the worth of goods and another part the worth of goods.
Got it.
See, now this question is basically a profit and loss question. But even if it would have been in a profit and loss chapter, I would have used this method. Now, how do I identify that this question can be solved using this method? Because if you just see the form of the question, I am mixing two things to form a third thing. Can you see that in the question?
Yes, ma'am.
If you see that format, you can use this cross method, irrespective of which topic the question is from. All right. Moving ahead. A chemist mixes two liquids, 1 and 2. 1 liter of liquid 1 weighs 1 kg. 1 liter of liquid 2 weighs 800 grams. And half liter of mixture weighs 480 grams. Then what is the percentage of liquid 1 in terms of volume in the mixture? Now half liter of mixture weighs 480 grams. So what should be the weight of 1 liter of mixture?
960.
Because everything is in terms of 1 liter, I would convert mixture also in terms of 1 liter. Okay. So 1 liter of mixture is 960 grams. What is the weight of 1 liter of liquid 1?
1 kg.
Which is, I can also write it as 1000 grams.
1000 grams.
And what is the weight of 1 liter of liquid 2?
800 grams.
So did you understand what I did in the cross? So now what is the proportion of liquid 1 to liquid 2?
Four is to one.
Yes, the proportion is 4:1. So now in this half-liter mixture, also the proportion of liquid 1 and liquid 2 will not change, right?
Yes, ma'am.
Basically, I am told what is the percentage of liquid 1. Sorry. So irrespective of this, you don't need this. If proportion of liquid 1 and liquid 2 is 4:1, what is the percentage of liquid 1? How do I convert this ratio proportion into percentage? For liquid 1, the proportion is 4/5, right?
4/5 into 100.
Will give you.
80%.
So of course, when liquid 1 is 80%, liquid 2 has to be 20%. You see that ratio being maintained?
Yes, ma'am.
Clear? It's a cat question, but see how simple the solution is. Okay,
Got it, ma'am.
moving ahead. Two alloys containing copper and iron in the ratios 5:8. So first alloy has the ratio 5:8. Second alloy has the ratio 5:3. Are melted in equal quantities. Now this is important. Find the ratio of iron to copper. Ulta ratio is asked in the final mixture. Now, when I say equal quantities, which means clearly the ratio in which both of the alloys are mixed is 1:1. Correct? So, but if I go back with the ratio format, it can be slightly complex. So, what I can do in such cases is, because the first mixture is 5:8, can I say the total will be a multiple of 13?
Yes.
And in this case, the total will be a multiple of 8. So let me assume one value, which is a multiple of both 13 and 8, because both are mixed in equal quantities. So tell me one value which is a multiple of both 13 and 8.
I think it will be 13 into 8 only.
Which will be? We don't know the date.
104.
Okay. So if I'm mixing 104 liters of, or 104 kg of, let's say, alloy 1, what would be the quantity of copper in that? 5/13 of 104 will give you
40.
80. No, sorry, yeah, 40, 40. Sorry, my mistake. And that is why iron will be how much?
64.
64. Similarly, with alloy 2, again 104 kg is only mixed. So what will be the quantity of copper with 5/8 of 104?
65.
65. And 3/8 of 104?
39.
So in the final mixture, the quantity of copper is 105 and the quantity of iron is 103. So what is the ratio of iron to copper?
103 to 5. Okay.
Did we understand this? So here we have not basically used allegations. We have taken directly ratio concept and solved it. With allegations, I can see from the options itself that to land down to this answer in this block is going to be little tedious. So this decision you can make with the questions.
Ma'am, how is the ratio 103 is to 105 and not 105 is to 103?
Because what I am asked is iron to copper and what I am found is copper to iron.
Okay.
Okay. All right. Oh, this looks little big. Two alloys of iron have different percentages of iron in them. The first of them weighs 6 kg and the second one of them weighs 12 kg. One piece of equal weight is cut from both the alloys. The piece from the first was mixed with the leftover part of the second alloy, and the piece from the second is mixed with the leftover part of the first alloy. As a result of which the percentage of iron became same in both the alloys. What was the weight of the each cutout part? So both of them are alloys of iron and both of them have different percentages of iron in them. Let's say in this the percentage of iron is M and in this alloy the percentage of iron is N. Now I'm cutting equal pieces of XX kgs from both. Now what is happening is this X kg is mixed over here and this X kg is mixed over here, and as a result of which the percentage of iron becomes same in both the alloys. Let's see how this can be done. Okay, so first of all, in the first part where it is 6 minus x kgs, what is the percentage of iron? M%. And the second part which comes from the other side, the percentage of iron becomes N%. Correct?
Yes, ma'am.
So this is the quantity of total iron in the first part, but quantity of iron is not same in both the alloys. Percentage of iron is same in both the alloys. So quantity upon the total quantity, which is 6 minus x plus x. Do we all understand this? This will give me the percentage of iron in the first part. Is equal to N% in 12 minus x plus M% in x upon 12 minus x plus x. Anyone who could not understand this equation, please ask.
So we are basically equating the two equations for the percentage of iron.
Correct.
That becomes the same when both alloys are mixed.
Correct. Did you understand the numerator part?
Yes, ma'am.
Okay. So now, of course, this minus x plus x minus x plus x gets cancelled. This is 6 ones are, this is 6 twos are. I'm left with 2 on this side. Because all the terms have the same denominator, I can ignore the denominator of 100 also. Agreed? So if I multiply
Yes,
this on
ma'am.
this side, what do I get? 12m minus 2mx plus 2nx is equal to 12n minus nx plus mx. How do I solve it further? I need the weight of cutout pieces, which means I need the value of x. Let's take all the terms with x on one side and without x on one side. So this is what? 12m minus n. And if I take with x on what side, what am I left with?
12m minus 12n is equal to 3mx minus 3nx.
Which means it is 3x into m minus n, right?
Yes.
So your m minus n gets cancelled. So what is your x coming down to?
4.
4 kg.
So 4 kgs is the weight of the cutout piece.
Correct. Because x was what we assumed as the cutout piece, right?
Got it, ma'am.
Okay. Let's look at this question. X and Y are two alloys which are made by mixing zinc and copper in the ratio. So in X, zinc and copper is mixed in the ratio 6:9. And in Y, zinc and copper is mixed in the ratio 7:11. If 40 grams of alloy X is melted with 60 grams of alloy Y to form a third alloy Z, What is the ratio of zinc and copper in Z? So, how do you want to do it? Again, if you see the numbers, if 2 or 4 is the answer, it is not easy to get that in the block easily, right?
Yes, ma'am.
So if 40 grams of alloy X is taken, can you directly find the quantity of zinc and copper from alloy X?
Yes, ma'am.
What will be the quantity of zinc?
In X, it'll be 16 for zinc, and
How 16?
16, 1 6.
How 16 but?
14 to 6 by
Yeah.
15.
Okay. Sorry. And copper would be 24,
24.
the remaining part, right? And in alloy Y, zinc would be
70 by 3.
possible. Just 7 by 18 of 60, right?
Yes.
So 70 by 3 is correct. And for copper, 110 by 3, I think.
110 by 3.
So this is from alloy X and Y. When I mix both of them, the total becomes in alloy Z, right? So in alloy Z, what is the total quantity of zinc? 16 threes are 48. 48 plus 70 will give you
118.
118 by 3. And here 24 threes are 72. 72 plus 110.
182.
182 by 3. So if I reduce these ratios, what do I get? Do we understand this?
Got it, ma'am.
So this is the ratio of the alloys in Z.
Correct.
Fine.
Zinc and alloy in, zinc and copper in Z.
Got it.
Okay. All right. Let's try this last question before we end the class for today. The ratio of metal 1 and metal 2 in alloy A is 3:4. In alloy B, the same ratio, same metals are mixed in the ratio 5:8. If 26 kg of alloy B is mixed with 14 kg of alloy A, it's the same as the previous question. What is the
Yes.
ratio of metal 1 and 2 in the new alloy? In fact, this is an easier version of the previous question. Metal 1, metal 2, alloy A, alloy B, and the new alloy. So in alloy A, what is the quantity of metal 1?
6 kgs and 8 kgs metal 2.
Correct. And B?
10 kgs and 16 kgs.
So it comes down to
2:3. Yes.
just, you have to be careful that you don't make a mistake of taking 26 kg of alloy A. They have written 26 kg of alloy B, so write it correctly. All right. So there are certain type of questions which we might not have done from one small concept was left. If you want, I can just take down that small concept first so that you can solve the remaining questions.
Yes, ma'am.
Okay. Let me take that small concept. Let's say, just to explain that as a concept, let's say in a container, I have 100 liters of pure milk. Okay. Now what am I doing is, I am removing 20 liters from the container and replacing it with 20 liters of water. So now what is the quantity of milk in the container?
80 liters.
And what is the quantity of water in the container?
20.
20. Okay. So now this is what is there in the container. Now I repeat this process again. I remove 20 liters from the container and I replace it with 20 liters pure water. So how much milk will be removed from the container?
40.
No. From this, I am removing 20 liters from the mixture, from the container. So when I remove 20 liters from the container, how much milk will be removed? Can I say because milk and water are in the ratio 4:1, the removal will also be in the ratio 4:1?
Yes.
So how much milk will be removed? 16. And how much water will be removed? 4.
4.
And I am replacing it with 20 liters pure water. So what is my final quantity of milk and water? Did you understand what we just did?
Yes, ma'am.
Okay. So when you have such type of a question where from a mixture same quantity is removed and replaced every time, of course you don't have to do this manually all the time. There's a simple formula which comes down to this answer, where the formula is, I'll explain the terms in the formula. Okay. X is the total capacity of the mixture or the total quantity of the mixture initially. So in our case, X is 100. Y is the amount of mixture always removed and replaced. So in our case, Y is 20. And N is number of times this is done. So in our case, N is 2. So if I apply this in our formula, what do I get? 100 minus 20, 80 upon 100 raised to 2, which is 64 by 100. Which means after 2 cycles, the quantity of milk remaining out of the total quantity is 64, and that is why the remaining 36 becomes water. Did we first understand this formula?
Yes, ma'am.
And now, if instead of 20 being removed every time, if different quantity is removed every time, my formula will become x minus y1 upon x into x minus y2 upon x. This is nothing but successive decrease into x minus y3 upon x and so on. Because every time the same quantity y is removed, I directly wrote it raised to n. But let's say in the first cycle, I'm removing 20 liters. In the second cycle, I'm removing 30 liters. In the third cycle, I'm removing 40 liters. Then my y1, y2, y3 becomes 20, 30, 40 respectively.
This is just for the quantity removed or for the quantity replaced as
And
well.
replaced. So whatever quantity will be removed, it will same will be replaced.
Okay.
Okay, so because questions after this, there are quite a few questions which connects to this concept. So I've done this. Try the remaining questions after this. If you are able to apply this at least in few questions, very good. If you're not able to apply, don't worry. We'll do those questions first when we meet next time.
Okay, ma'am.
So after
Yes,
this,
ma'am.
there are 14 more questions remaining. Try solving those questions. See how many you can solve. And if you have doubts in any questions, get them back and we'll take it up next time. All right. And I think we'll end the session for now today.